There.
That's enough.
I don't know.
Vicky won't be
And I changed the assignment sheet too, you know.
You did?
I'm trying, yeah, I'm
No
trying.
homework for the rest of the
No,
semester?
no,
Oh.
no.
Nice. Nice.
Although it is reducing the amount of homework.
Oh.
Oh yeah, I was
And
already here
it's-
changing it.
It's gonna reduce the amount of material we learn as well.
Right on.
I mean, boo, boo.
Yes, that's not working.
Okay, so number 3, you guys said you couldn't do. So you got the integral over the curve, d3y dx. So this is the p. This is the p.
Oh, wait, oh my god.
Oh
Wait.
my god.
Oh, yeah,
wait, no, never mind.
This is the q.
Wait, never mind.
I just realized it was a circle.
Yeah, that's a circle, right? So you need
And
You
this
didn't
is
need it.
great,
You
yeah.
just
See-
need to do zero.
You just do 2 times the area of the circle.
At first, okay, this is before I remember the centroid thing.
I give up on number
That's
one.
why I
son.
forgot.
Okay, what the heck? Let's just do it again anyway. We've got it up on the board. So at least do you know the formula part?
Yeah.
Okay, what is it?
This
Partial
is literally just the area
Q
of the
with
circle.
respect to
I know.
Partial
See,
of q
that's
with
tricky,
respect
that's
to
tricky.
x
minus
minus the partial of t with respect to y
minus 1.
minus 1.
Minus EX
I don't think there's a minus
There's
1.
no
Oh,
minus one.
shoot.
Where did the minus 1 come from? dx dy.
Yes.
Alright, so
Five.
what is the partial of q with respect to x? Isn't that just 5?
Yes.
What is the partial of p with respect to y? Isn't that just 3?
Shit.
5 minus 3 is 2.
The answer is 0.
This is before I remember
This
the
is too
centroid.
high.
Oh, it's 2 pi.
Oh, no, that's not
You
right.
don't-
Zero.
No, but you're not going to do the centroid thing because there's no x or y. You only use the centroid thing when an x or a y comes out here.
Oh, because I tried to do it with the dx dy with the root thing, it didn't work out.
So if we integrate this over the circle, x squared plus y squared equal 1.
Like, isn't the integral of work on a closed surface 0?
Not all the time, only if the force vector is a gradient. Remember?
It's not a gradient.
Is this a gradient of something?
3xy plus 5yx. Oh wait, no.
It's 8xy.
No, so no, it's not always 0. So this one you cannot,
3xy plus 5y.
oh my goodness.
You just flipped it.
So we're gonna go over the circle counterclockwise. I'm thinking, what's the best way to do it?
Oh,
Should we change it to polar?
Isn't it just 2 times the area of the circle though?
yeah.
Because double integral dx dy over omega would just be 2 times the area of the circle, right?
Oh yeah.
No, but it's not omega, it's a curve.
It's
Where
a
the-
curve.
The curve
It's not a, it's a curve,
The
it's,
surface
it's-
or the
it's not
omega
this
the
area, it's, we're going over the circle counterclockwise like this.
circle, so the area is pi. So pi times 2 is 2 pi.
Wait, no, that's what I was thinking too.
Yeah, because if you bring the 2 on the outside, that's the area of the circle. Is it?
It's just change the polar.
Oh, I see what you're saying. If you put the 2 on the outside, dx dy,
Yeah.
this gives you the area of the circle.
Yeah. That's not what I did initially, but that's what I realized. Like,
Oh, yeah. So the answer is just 2 pi then.
Yeah, wait. But can you like do it?
Wait, is that the answer?
Yeah, that's the answer.
Yeah, I think so.
Yeah.
Wait.
Yeah, that's right.
Wait.
But then
Wait.
but then if you had the x there, then that's like the x coordinate of the centroid thing, right?
Yeah.
If you have the y there, that's the y coordinate of the centroid thing.
Is there any way to do it without realizing that? Because I tried to do it without realizing that initially. And
Yeah, then you gotta integrate, okay, so then you would have to integrate with respect to y first, which will go from negative root 1 minus x squared to root 1 plus x squared. Then you integrate with respect to x, goes from negative 1 to 1.
yeah, I feel like it didn't come out
Oh yeah, they come out for me. Wait, why is it dy dx? I think dx.
No, yeah, we can do it in whatever order that you want to.
Because when I did dx dy.
Okay, well, let's see, let's work it out then. So if you integrate, the integral is gonna be y from negative root 1 minus x squared to root 1 minus x squared. So that's gonna be 2 root 1 minus x squared, is that correct?
Yes.
Yeah.
Now you gotta integrate that with respect to x.
Trig substitution.
Oh.
No, you can, but if you realize that, hey, that's the graph is a semicircle, right? So that graph is a semicircle of radius 1. So the area from negative 1 to 1 is pi over 2. So you're going to get pi over 2 times 2. Oh, I forgot to put the 2 here, so there should be a 2. So there's a 2. And so it's going to be 4 times pi over 2, which is 2 pi. Yeah, otherwise you got to do trig substitution if you don't realize that's a semicircle. And you guys remember how to do trig substitution? X equal 1 sine theta.
Okay.
Okay, it's pretty easy. It's very mechanical. Okay, so this is what we're doing today. So the next section is actually surface area, but I actually put surface area on the last test. But it's really good to do surface area anyway. Okay, I'm looking for the problems. So you guys remember the surface area problem, yeah? Formula?
It's like the derivative each partial squared plus 1, right?
Exactly. So I only assigned 2 problems from 19.5 because that's review. But I also assigned a couple problems from 19.6. So, 19.5 rather. So, and it has to do with, now that you know how to compute surface area, now can we compute the mass of a surface? So let's do the example in the book. It's pretty good. I gotta make this thing
So
bigger.
this part's 19.5.
Yeah, so 19.4 is surface area. 19.5 is to compute the mass of a surface. So those of you following on the video, we are at the bottom of page 846. There's a problem there. It says find the total mass of a material surface. I'm going to erase this. Where S is Z equals XY. So there's some kind of graph. Is that a hyperbolic parabola? Could be, yeah. And above the circle, x squared plus y squared is less than or equal to 1. I wonder why they put the greater than or equal to 0, because it is already. See, so do you guys understand where this surface is? So here's the circle, x squared plus y squared equal 1. And then we have the surface that's above it like this. Okay, so we know how to compute the surface area, right?
Yeah.
Okay, let's write that down. What's the formula for surface area? Double integral square root of, I'm going to leave a space here, square root of the partial with respect to x,
Plus.
which is what? What's the partial with respect to x?
Y.
Y squared plus the partial with respect to y, x squared plus 1 dx dy, correct? Okay, however, what if we want to compute mass? Now, how do we compute mass?
You have to multiply by the wall.
Mass is equal to surface area multiplied by density of a surface, of course, not a volume density, a surface density. Okay, what kind of density do you have when you have volumes? Like, well, kilograms per cubic foot.
Sure.
But for a surface, it would be like kilograms per square foot,
Okay.
you know? Because it's a surface density.
How does that work though?
Because surface area is measured in like feet squared,
Yeah, but like,
and then you have kilograms per feet squared. They cancel out, you just get kilograms mass.
well, yeah, but like, how do you have weight in?
You have a surface, can have a weight, right? You can put it on the scale,
But isn't it like infinitesimally small? Or like
infinitesimally thin,
thin?
but it still has weight, right?
But then do you not know what the thinness is?
We have to assume it's infinitesimally thin.
Okay.
Okay, anyway, so we just look at the dimensions, like, so this will compute a surface right here, right?
Oh, yeah.
Yeah. So now all you have to do is multiply it by the density function, just like we did on the last test, except we did it with volumes. Now you're doing it with surfaces. So it says the density at each point is proportional to the distance from the z-axis. You guys see that? The density at each point is proportional to the distance from the z-axis. So what is my distance function? I mean my density function. So if you have a point here, it's proportional to the distance from the z-axis. So the z-axis is coming out like this, right? So how do you find the distance right there? If this is the origin, 0, 0, this is the point, it can be anywhere. How far are you from the z-axis? Wouldn't it be the square root of x squared plus y squared?
Yeah.
So if it's proportional to the distance from the z-axis, it would be the square root of x squared plus y squared times the constant of proportionality, but that can be thrown out on the outside anyway, yeah? Okay, so now all you gotta do is compute this integral. So you got surface area, which we did before, then you multiply that by the density function, and then we integrate over omega, which is this, right? Because if you smashed it down onto the xy plane, this is what you would see. Now, how should I do this integral? Should I do it rectangularly or polarly?
Polarly.
Yeah, polarly, because you got x squared plus y squared, right? So this is r squared, this is r squared, this is r dr d theta, right? So that's a way better integral to do. I mean, it's way easier to do it. So what is the square root of r squared? R, well, absolute value of r, but it's going to be positive, times the square root of r squared plus 1 times r dr d theta, but r times r is r squared. Okay, now what are my limits? Oh, it's a double integral. So if I integrate with respect to r first, r is going to go from 0 to,
Square root of x.
no, look, 1, 0 to 1. And then theta goes from 0 to 2 pi. So this is our, this integral will tell me the mass of this material surface. That's the title of the section. Mass of a material surface. Okay, so now, here's the hard part for you guys. How do I do this? Tabular?
What?
You can't do tabular?
Yeah,
Okay, wait, time out. How do we do tabular? So
Well,
are you saying take this derivative down to 0?
Yeah.
Can't undo.
And this one you gotta repeatedly integrate. Okay, what's the antiderivative of that? Okay, that's right. We're not gonna do tabular. You only do tabular when like this one is like e to the something, cosine something, or sine something, yeah? Okay, we haven't hit it yet.
Oh!
No, partial fractions, there's no fractions
No,
here.
it's trig.
Trig substitution. Now, if that was just r to the first power, then we could just do u substitution, but it's not. So we gotta do a trig substitution. Now what is that substitution? R equals 1 tangent theta. That's right. dr is equal to secant squared theta d theta. Plug it in. Integral from, what are the new limits of integration?
0 to pi.
Okay, we're doing this one first, yeah? We're doing this integral first. What are my new limits of integration? 0 to pi over 4. R squared is tangent squared theta. Square root of tangent squared theta plus 1 is secant squared theta. And dr is secant squared theta d theta. So what kind of integral, what kind of monstrosity do we have here? This is equal to secant theta. And so we have tangent squared theta secant cube theta.
And then u
Theta.
substitution with secant.
Yes.
And e equals.
You think
Oh, no,
it's
no,
that
it's
simple?
not.
U substitution
It's
with
not, it's
secant.
not, it's not, it's not. I thought it was good that the derivative of secant was secant.
This looks like a difficult problem. Okay, this is what I'm thinking is gonna have to happen. you're gonna have to change that
Oh my
to
God.
secant squared theta minus 1. See, in the book, here, let me show you what the book does. The book just assumes you guys can integrate this. Let me just show you what the book does.
Oh.
Oh, man.
Oh. So they just skip the entire integration.
Yeah, so they get here, that here, and then boom, it's equal to that.
Imagine.
They must use Wolfram Alpha.
No. This is the same book I used when I was in college in 1970 something.
By that
So
you did-
no, there was no Wolfram Alpha. So you got the integral from 0 to pi over 4 of, if you multiply that out, you get secant to the 5th theta minus secant to the cubed theta d theta. Now remember, these were on our project, remember at the very beginning of the year? You had to do all the trig functions, the powers up to the 6th power. So like this one, remember I told you guys to memorize this one?
Secant x tangent
1/2
x
secant theta tangent theta minus ln.
ln
There you go.
secant x plus
1/2 secant theta tangent theta
Oh, I guess, yeah.
minus
plus 1/2 natural log absolute value secant theta plus tangent theta. Now, if you don't memorize it, what's gonna happen? You gotta do integration by parts. And then what about secant to the 5th?
I got it.
Yeah, you guys have it, but you guys remember how to do it.
I'm reflecting it from memory.
You have to.
Okay, so again, the hardest part of this problem is you guys gotta integrate these things.
Secant third, secant cubed x tangent x.
Like minus 2 points if we don't integrate.
No,
Minus.
that's the point of the whole problem is to do the integral. Does anybody remember how to integrate secant to the 5th?
You
Split
split it up.
You gotta split it up, so
Do
what?
Secant to the
secant cubed
third.
and secant.
Okay, so you go secant cubed times secant squared, and then what?
You translate secant squared to tangent. Or 1 minus tangent. No.
Yes.
Is it secant?
Okay, integral of secant to the 5th theta d theta is equal to.
And then you do
integral-
them, yeah, and then you do the increasing by parts from there, right?
Just do, no,
What?
no.
That's
You
secant.
get secant
No.
to the 4th, and then you do 2.
So
Hey,
you,
Mr. Park, I just
hello,
want to say, I
Hold
passed
on.
calculus.
I would hope so.
I got an A in Calc 3, and I think
No,
that's
this
all the
thing.
math I'll ever be doing. Yeah!
Oh, it's over here. We're trying to do the integral of secant to the 5th theta.
Oh, have fun.
Okay, bye.
Enjoy
Wait,
your
wait.
Oh, what?
Where did you go again?
The University of Chicago.
That's right.
Oh,
Whoa.
And what are you majoring in?
I don't know.
You don't know.
So then you need to take more math then.
No, I finished my math requirement.
Yeah, but what if, no, not if you major in engineering.
Did they take your calc?
They did take my calc. They take 1/4 of your calc. Yeah.
And then what, you have to take a test then?
I took a accreditation exam, and I got put into 3rd semester calc as opposed to 2nd. And then
That would have been
I-
a waste though if you did. If you
Second?
didn't- Yeah.
Yeah, it would have been. So
Oh.
I'm glad I took it, and because I took 3rd semester calc, I get back credit. So I get credit for the first 2, and my 3rd semester is counted towards my general elective credits.
Oh, that's good.
So I got 3 for 1.
Yeah.
It was good. But I might go into econ. I want to do comp sci as a minor, so we'll see.
Econ and comp sci.
I might go into econ. It's probably more like English though, because I like writing papers.
I've never heard of
One of my best friends is a math major though. Like doing proofs and stuff.
You got Nathan too.
No. My best friend's at the university.
Oh.
Nathan.
Yeah, I don't think Nathan's majoring in math.
Oh.
Wait, what's Nathan majoring?
I think he's
Well-
doing econ.
Really? Yeah, that sounds like him.
I was doing chemistry.
No, you major in econ, then you get a job, your first job out of college, you make 100-something thousand a year.
Well, if you
Oh.
You can imagine
if you
econ.
make
Versus
it.
I'll major in English and I'll get 20,000.
Yeah, but you're gonna love what you do.
I will. I'll live a fulfilled life. All my artistic outlets are just my job. Yeah. I don't know. Okay. Well,
Yeah.
bye, Mr. Park. It's
Okay,
nice to see
yeah,
you.
good to see you.
Enjoy your time.
Okay,
Enjoy this.
bye.
Bye.
So you split it up into secant cubed.
And we're back.
I was
I was on
Back to
third.
reality.
I was gonna retake all my AP taking classes so that
What?
college would be easy.
College,
Yeah.
then you'll waste so much
Super
money.
easy for
Waste
like the
time.
first year.
You know what I decided? You guys did this already. Remember the project? We just talked about it 2 minutes
How do you
ago.
solve it?
Did I give you guys back your
On
projects?
memory.
What
Wait, we
project?
just have it back? It's a project? That was just homework.
Remember our integral review at the beginning of the
That
year?
was just homework.
Wait, how do you?
Yeah, it was homework, but it was like a project. You had to like fill in the 36 boxes, right? You know what? I'm gonna spend the rest of this period passing back to the homework.
I
after
just
we
emailed it
finish.
to you, so I still
Yeah, I
have
have.
it.
Oh, okay, so if you email it to me, then you don't have, I'm not gonna pass it back.
The rest of this.
Oh, and then
You know what? You guys are gonna do this. I do everything. You guys gotta do something. Okay, so we're done. So tonight's homework only got 4 problems. 2 surface areas, which you already know how to do. You gotta refresh the assignment sheet then. And then 2 compute the mass. So you multiply the surface area thing by the density function. It's quite easy.
So are you gonna give us homework on Friday?
No, obviously did not look at this assignment sheet. It says no homework.
What about on
I have never given homework ever on Christmas vacation, spring break, or.
what about on Thursday?
Oh, do we have class tomorrow?
Well,
Yeah,
since,
Thursday.
okay, since I reduced the homework, there might not be homework on Thursday either.
Nice.
You're meeting.
Okay, I'll tell you what, if you do it, no homework on Thursday.
If
If you actually do the 4 problems,
Okay.
Oh.
or at least attempt it.
Okay.
At least.
I'll come to extra help too in the morning.
These problems are simple, this is surface area.
No.
This is
Why
review.
are you only giving us 4 problems?
No way, this is
Only
review.
Oh, you have to do
Yeah,
that
4's a
in a while.
lot.
There's like a blind man in a dark room looking for a black cat who's not there. No way!
You like back.
It's like a shot in the back.
Hold up for you.
No way!
For the second movie, yeah.
You both look 3 the same.
Get the game.